I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Algebra Unit 8, Lesson 3. We're going to solve quadratics by factoring. And when I mean solve, I am talking about finding the solutions. And remember, the solutions are the x-intercepts, which we also call the zeros, which we also call the roots. So all of those are interchangeable. So probably x-intercept is the thing that makes the most sense, especially when you think about a graph. So basically, I'm trying to figure out where does this quadratic function cross the x-axis. Remember, it can cross once, twice, or none. And so the problems that we're going to look at are going to cross either once or twice. And in class, I'll talk more about what happens when it doesn't cross at all and what would happen here. So our first example is f of x equals x squared plus 4x minus 21. And so we're going to solve this by factoring, which means we are going to factor this quadratic. Now, because we're solving for the x-intercept, we want the y to be equal to 0. So I'm going to put f of x equals 0. And now I'm going to factor this quadratic, which we already learned how to do, and then I'm going to show you what to do from there. So I'm going to do this, negative 21 at the top, positive 4 at the bottom. Factors of negative 21, negative 1 and 21, negative 3 and 7. I think that's it. Okay, so negative 3 plus 7 is 4. So those are my factors. So then I'm going to write my factors as x minus 3, x plus 7, and that equals 0. So now what happens is this is multiplication. And so if one of these factors, okay, if this is 0 or if this is 0, if either one of those is 0, then this equation would be true. And so what I'm going to do is I'm going to set each of them equal to 0 separately. So x minus 3 equals 0 and x plus 7 equals 0. And I'm going to solve for x. So in this case, x equals 3. And in this case, x equals negative 7. So there are two solutions. There are two x-intercepts. So my solutions are 3, 0, and negative 7, 0. All right, our next example is set up for us really already because it's already set equal to 0. So we are going to factor this. So I need to find factors of 10 that add up to 7, 1 and 10, 2 and 5. That was pretty simple. 2 plus 5 is 7. So x plus 2 times x plus 5 equals 0. So again, I'm going to set each factor equal to 0. And then solve. Minus 2, x equals negative 2. Minus 5, x equals negative 5. So my solutions are negative 2, 0, because again, the negative 2 is the x, the y is 0, and negative 5, 0. If you remember, because a here is 1, positive 1, that means this parabola is going to be concave up. And so we could kind of even think about what this graph would look like. We know it would cross at negative 5 and at negative 2, and we know it would open up. So we know it would look something like that. That's just a rough sketch. All right, our next example looks a little bit different than the others. So it says x squared plus 2x equals 8. But remember, we need it to be equal to 0. So we're going to subtract 8 on both sides, which leaves me with x squared plus 2x minus 8 equals 0. Now we're ready to factor. So I'm going to find factors of negative 8 that add up to 2. Negative 1 and 8, negative 2 and 4. So negative 2 and 4 are my factors. X minus 2, x plus 4 equals 0. Then I set each factor equal to 0 and solve. So x equals 2 and x equals negative 4. And again, notice how I am writing my solutions as coordinates because I want you to keep in mind and notice that these are ordered pairs. These represent where the quadratic crosses on the x-axis. All right, I have one more example for us. X squared plus 16 equals 8x. Again, I need this to be equal to 0, so I'm going to subtract 8x on both sides. And I'm going to make sure I put this in the right order. So x squared minus 8x plus 16 equals 0. So now I need to factor. I need factors of 16 that add up to negative 8. Well, remember, if my c is positive but my b is negative, then both factors need to be negative. That's the only way that's going to work. So it looks like negative 4 and negative 4 are my factors. So this is going to be x minus 4 times x minus 4 equals 0. And again, I'm going to set each of them equal to 0 separately. And what we'll notice here is that x equals 4 for both of them, which really means there is only one solution, and that solution is 4, 0. So that means that this quadratic function only crosses the x-axis one time. There is just one solution.
I've been waiting way too long. Yeah. I've been out here trying to get it. Yeah. I've been waiting way too